This is Dreamtime Science, where we turn fascinating discoveries into bedtime companions. Tonight's journey promises something genuinely intriguing. You know what's fascinating? The way clouds drift across the sky, almost like they're alive, constantly changing shape and hiding little secrets. I've been thinking about how something so soft and fleeting can actually tell us so much about the weather and even the world around us. Tonight, I want to share some of those quiet wonders about clouds that might just make you see the sky in a whole new, peaceful way. A soft tap of the like button or a whispered subscription tells me these calming discoveries resonate with you. What aspect of science brings you the most wonder? First, let's create the perfect space for learning. Cocoon yourself in comfort, release any lingering tension, and let your breath become soft and steady. High above the gentle rolling cradle of the earth, where the wind whispers in secret currents and the sun weaves shifting patterns of gold, clouds wander. They are the sky's drifting poetry, veils of vapor that dance between earth and cosmos. For as long as there have been human eyes to gaze upward, clouds have summoned awe and wonder. They are the ever-changing theatre of the heavens, sometimes playful, sometimes ominous, always alive with mystery. In the earliest flickering of human consciousness, when the world was still half glimpsed through the haze of dawns and dreams, clouds became the canvas upon which imagination painted its stories. Think of the first people huddled around fires, their faces lit by the glow of embers and the mirrored luminance of the moon. Above them, the night sky, a vast, unknowable expanse, was streaked with ghostly shapes that morphed and melted from one moment to the next. How natural it was to see in those mists the footprints of gods, the breath of spirits, the restless wanderings of ancestors. Many ancient cultures wove the clouds tightly into their mythologies, their appearance and disappearance taken as omens, messages, or even deities themselves. In Greek mythology, the clouds were the visible cloaks of the gods. Zeus, king of the heavens, was said to gather the clouds around him, his thunderbolts flashing from their depths. The Greeks imagined the Nephili, cloud nymphs, who watered the earth and nurtured its life. It is not difficult to picture a shepherd lying on a hillside, staring upward and tracing stories among the billows, a great stallion galloping across the sky, a ship adrift on the celestial sea, a face, kind or cruel, emerging from a boiling mass of white. In the myths of India too, clouds carried sacred significance. The god Indra, bringer of rain, rode upon Airavata, his mighty white elephant, and loosed the monsoon from the cavern of the sky. In the Rig Veda, clouds are the vessels of Soma, the divine nectar, their rains a blessing upon the earth. When the monsoon winds gather and the clouds tower in dark procession, it is as if the very heavens are being drawn in to a cosmic festival, a dance of generosity and renewal. The Maori of Aotearoa, New Zealand, knew the clouds as the breath of the great sky father Ranginui and the earth mother Papatuanuku. When the clouds hung low and thick, it was as if the parents, long separated by the strength of their children, were reaching out to touch once again. And among the Inca, who built empires high in the rarefied air of the Andes, clouds were considered the homes of the Apus, the mountain spirits, who watched over fields and streams and the people who depended on them. There is a universality to these stories. Across continents and centuries, clouds have been seen as bridges between the mundane and the divine, as both messengers and mysteries. Their mutability, here one moment, gone the next, invites us to contemplate impermanence, transformation, and the unseen forces that shape our world. But clouds have not always been only the province of gods and spirits. They are deeply woven into the fabric of folklore, those tales told in quiet moments, passed from parent to child. In rural England, there are sayings that link the shape and colour of clouds to the arrival of fairies or the portents of weather. Mackerel sky, not long wet, not long dry, goes one rhyme, inspired by the rippled altocumulus clouds that resemble the scales of a fish. In Japan, the traditional art of ukiyo-e, pictures of the floating world, often features clouds as swirling, ephemeral presences, both covering and revealing, hinting at the beauty of transience. Children everywhere, it seems, have played the ancient game of cloud watching, lying on their backs in grass or sand, squinting at the sky and naming what they see: a dragon, a castle, a dog chasing its tail. In these moments, the clouds become a shared dream, fleeting and unrepeatable, an invitation to wonder and to see the extraordinary in the ordinary. As human societies grew and changed, as we moved from nomadic wandering to settled cities, the clouds remained both a comfort and a challenge. Farmers learned to read their shapes as signs of rain or drought. Sailors watched the horizon for towering cumulonimbus, thunderheads that might spell a storm. Even in the heart of the world's busiest cities, a patch of sky glimpsed between buildings can draw the gaze upward, away from the bustle and the noise, into a quieter, broader realm. Yet as much as clouds have inspired our stories and shaped our days, they have also haunted our dreams. The shadowed underside of a storm cloud, roiling and dark, has always carried a hint of menace. In Norse mythology, the thunder god Thor rides with the storm, his hammer echoing in the clouds. The ancient Chinese imagined dragons coiled within the mists, bringing both rain and chaos. And in the book of Genesis, after the flood waters receded, it was in the clouds that God set the rainbow, a sign of promise and warning both. With the coming of the scientific era, the realm of clouds took on new dimensions. No longer only the territory of myth and legend, clouds became the focus of observation, measurement, and theory. Yet, even as we began to unravel their secrets, a sense of wonder remained. For to look at a cloud is to see, in one glance, both the immediate and the infinite, water droplets suspended in air, and the breath of the planet itself. Science fiction, that ever-curious child of science and imagination, has found in clouds a rich source of metaphor and possibility. In the tales of distant worlds, clouds conceal floating cities, airborne leviathans, and the secrets of alien atmospheres. Writers from Jules Verne to Ursula K. Le Guin have conjured visions of airships drifting through endless cloudscapes, explorers seeking hidden lands above the storms. Sometimes the clouds themselves are alive, intelligent nebulae, sentient mists, beings of vapor and light. In Ray Bradbury's The Rocket Man, clouds become a symbol of distance and longing, the barrier between earthbound lives and the unreachable stars. The astronaut's family watches the sky, tracing his journeys not by roads or rivers, but by the shifting formations above. In Hayao Miyazaki's animated worlds, clouds are portals to adventure, both shield and sanctuary, a place where ordinary rules dissolve and the world is remade in the colors of dream. There is a persistent fascination with what might lie within or beyond the clouds. Are there lands of perpetual mist where sunlight is a rumor and the ground is never seen? Could life exist in the dense, swirling clouds of Venus, where atmospheric pressure crushes and heat scalds, yet where some hardy form might drift on the wind? In the imaginations of science fiction, clouds are more than weather. They are mystery, frontier, and invitation. Yet the true power of clouds, in both story and science, may be their ability to make us pause, to look upward, to be drawn out of ourselves, to see the world not as a fixed place, but as something shifting and alive. When we watch the sky, we are reminded of our own smallness and our capacity for wonder, of how much lies beyond the reach of our hands, but not our minds. Throughout history, clouds have marked the boundaries of knowledge and faith. They are the hiding places of thunderbolts and rain, the shrouds of mountains, the curtains that open and close on the drama of the sky. In some traditions, the afterlife is imagined as a realm of clouds, a place of rest, of peace, of unending change. Angels are said to dwell among the clouds, their wings stirring the air, their songs carried on the wind. There is something profoundly democratic about clouds. They belong to no one, yet they are seen by all. The richest king and the humblest shepherd gaze upon the same sky. In the Old Testament, the prophet Elijah looks for a sign, and it comes as a cloud no bigger than a man's hand rising from the sea, a promise of rain to a parched land. In the poetry of Basho, a single cloud drifting over the mountain becomes a meditation on solitude and connection. Clouds have also been the source of anxiety and prophecy. In ages past, a sudden darkening of the sky might signal plague, war, or the anger of the gods. Even today, in the era of satellites and forecasts, there is something uncanny about the approach of a storm. The gathering of clouds can unsettle the heart, awaken old fears, remind us of forces beyond our control. Yet their passing is equally a relief, a return to light, to blue, to the fragile sense of normalcy that comes when the sky clears. The language we use for clouds is revealing. We speak of being on cloud 9, of having a cloud over one's head, of ideas clouding our judgment or clearing up at last. In painting, clouds are the test of a master's skill, the ability to capture substance and insubstantiality, to conjure form from formlessness. In music, from Debussy's New Ages to Joni Mitchell's Both Sides Now, clouds become metaphors for memory, change, and the endless dance of perception. It is perhaps this combination of beauty and uncertainty that makes clouds so enduringly fascinating. Unlike the sun or the moon, which follow predictable paths, clouds are creatures of whim and weather. They can appear soft as lambs, glowing with the rose and gold of sunset, or towering as mountains, dark with the promise of rain. They are at once familiar and elusive, always present, yet never quite the same. As night falls and the winds shift, the clouds above us continue their silent journey. Somewhere a child looks out a window and asks what they are made of, where they go, why they change. Somewhere else, a poet puts pen to paper, struggling to describe the way the clouds caught the last light of evening, how they seemed to hold a secret just out of reach. Scientists, too, look upward, measuring, naming, seeking the patterns behind the beauty. Yet, for all our curiosity, clouds remain, in some essential way, unknowable. They are the sky's living riddles, dissolving even as we try to grasp them. To watch them is to be reminded that not everything must be understood to be loved, that the world's greatest wonders are often those that slip through our fingers like water or wind. In the gentle hush before sleep, when the mind drifts and the boundaries between thought and dream grow thin, the image of clouds lingers. They are the guardians of the night sky, the keepers of stories both ancient and new. Outside your window, perhaps, a solitary cloud glows silver in the moonlight, a silent companion to your own wandering thoughts, inviting you to follow, to imagine, to wonder. And as you let your eyes close, the question persists. What shapes, what stories, what secrets lie hidden in the dancing shadows of the sky? The answer, as ever, is both just beyond reach and waiting in the next moment of looking upward, where the world is painted anew with every passing cloud. Evening deepens, and the sky, that ever-shifting stage, is alive with pageantry. The clouds, those spectral dancers of the troposphere, move with purpose and mystery. One could easily be lulled into thinking their choreography is simple. Water rises, cools, condenses, and clouds are born. But as you settle into the gentle hush of night, allow your mind to peer behind the curtain. For the truth is, each cloud overhead is an improvisation in a complex ballet, a fleeting structure held together by forces more subtle and intricate than can be captured by a single ink stroke in a textbook. To understand the science of clouds, one must learn to listen for the silent music of vapor and air. Begin, if you will, with a single invisible molecule of water vapor. It emerges from the surface, perhaps from the rough skin of a river or the whispering blades of grass after rain. Heated by sunlight, it escapes its liquid comrades and enters the invisible realm of the atmosphere. It is a solitary traveller, buoyed upward by the gentle churn of convection. But its journey, though guided by simple rules, is woven into a tapestry of staggering complexity. The path of this vapor molecule is shaped not only by temperature and pressure, but by the restless eddies of turbulence. Air, though it feels still in a quiet field, is rarely at rest. It swirls and tumbles in vortices large and small, from the vast, slow currents that arc across continents to the rapid, chaotic flickers that dance around your fingertip. The molecule's fate depends on where it wanders within this invisible labyrinth. As it rises, the air around it cools, for the atmosphere is a great gradient of temperature, declining as one ascends. This cooling is not a simple subtraction of heat, but a process governed by the laws of thermodynamics. The air expands as pressure drops, and in expanding, it surrenders some of its warmth, a process meteorologists name adiabatic cooling. It is this gradual loss of heat, this gentle unwinding, that carries the vapor ever closer to a threshold, the dew point. But the dew point is not a fixed gate, nor is it uniform across the sky. It is a shimmering, shifting boundary, changing with every breath of wind, every pool of sunlight, every exhalation of the living earth. When the air cools enough for the vapor to reach this boundary, and the air can hold no more, condensation begins. But condensation, too, is not a simple matter of water suddenly appearing. It is a delicate negotiation at the molecular level, a gathering of vapor around tiny seeds, microscopic motes of dust, salt, or pollen, known as cloud condensation nuclei. These nuclei are critical to the birth of every cloud. Without them, vapor could remain adrift and uncondensed, even as the air becomes supersaturated. Imagine a room growing ever more humid, yet the walls remain dry, for there is nowhere for droplets to take hold. In the open air, however, the world is never so pure. The atmosphere teems with these motes, blown by winds from deserts, forests, and oceans, from volcanic plumes and the exhausts of cities. Each one is an invitation to water vapor. Cluster here and become more than yourself. A single droplet forms, then another, and soon thousands, millions, each minuscule, perhaps just a few micrometers across. Alone, each is invisible, but together they scatter sunlight, painting the sky with the soft whites and greys we call clouds. Yet even here, in this seemingly well-understood process, subtleties abound. The size, composition, and abundance of condensation nuclei influence the cloud's appearance, its brightness, and even its likelihood to rain. A cloud seeded with salty ocean spray may glisten in the sun, reflecting more light back into space. Another, born over a smoky city, may be home to droplets tinged with soot, their surfaces different, their capacity to coalesce into raindrops altered. The ballet continues. Within a growing cloud, air is rarely still. Warm air, buoyed by its heat, continues to rise, carrying with it fresh vapor from below. As it ascends, droplets are swept upward, sometimes growing as they collide and merge. In places, the rising air cools beyond the freezing point, and ice crystals begin to form alongside droplets. Here, new dances emerge, between liquid and solid, between condensation and deposition. The cloud becomes a crucible of phase changes, of energy exchanged in silence. Each change, be it melting, freezing, or the subtle leap from vapor to ice, shuffles heat and moisture, driving further turbulence within the cloud. Consider for a moment the extraordinary complexity that arises in a single cumulus cloud. Its base may be just a kilometer above the ground, but its top might soar to heights of 6 kilometers or more, where temperatures plummet far below freezing. Within this volume, countless processes unfold in parallel. Droplets evaporate and reform, Ice crystals grow by stealing vapor from their liquid neighbors, a process called the Bergeron-Findeisen mechanism. Here, water's quirks are on full display. Ice can form at temperatures above freezing if the right surfaces are present, and supercooled droplets, liquid water below 0 degrees Celsius, can persist in equilibrium, awaiting a crystal or particle to trigger freezing. What appears as a single white puff is, in truth, a riot of microphysical processes, each with its own timescale, sensitivity, and feedbacks. The larger the cloud, the more intricate its internal structure. Narrow updrafts carry warm, moist air rapidly upward, while cooler downdrafts bring air back down, often loaded with evaporated droplets. The boundaries between these currents are blurred by turbulence, a phenomenon that, even now, resists complete mathematical description. Turbulence, with its wild fractal eddies, is the great unsolved riddle of classical physics. It renders prediction of cloud evolution a challenge that tests the limits of supercomputers and human ingenuity alike. All this takes place within the lower reaches of the atmosphere, the troposphere, a realm that stretches from the ground to around 12 kilometers high. Here, clouds are most at home, shaped by the daily interplay of sunlight, Earth's warmth, and the restless motion of air. Yet even in this familiar region much remains unknown. How precisely does a cumulus cloud decide to become a thunderhead? Why do some clouds produce rain while others remain dry, drifting as silent witnesses to the day's passing? Scientists have long sought to answer these questions. They have launched weather balloons, flown instrument-laden aircraft through clouds, and orbited satellites overhead. They have built wind tunnels and cloud chambers, seeking to replicate the conditions of the sky in miniature. Yet, for all this effort, the cloud's interior remains a place of mystery. The equations that govern the growth and decay of clouds are beautifully simple in theory, but devilishly complex in practice, for they must account for countless variables: humidity, temperature, pressure, wind speed, turbulence, the size and chemistry of nuclei, the ever-changing patterns of updrafts and downdrafts. To illustrate this complexity, consider the case of cloud albedo, the measure of how much sunlight a cloud reflects back into space. It seems at first a straightforward property. A thicker, denser cloud should reflect more light. Yet the reality is more nuanced. The size of the droplets matters, for smaller droplets scatter light more efficiently than larger ones. A cloud composed of many tiny droplets will gleam brilliant white, while one with fewer, larger droplets may appear grayer, even if its total water content is the same. The source of the nuclei, the history of the air masses, even the presence of certain pollutants, all can shift the balance of droplet sizes, and thus the cloud's reflectivity. This is not merely an academic curiosity. The brightness of clouds has profound consequences for Earth's climate. Bright clouds cool the planet by reflecting sunlight. Darker clouds absorb more, warming the air below. The interplay between clouds and sunlight is a delicate lever in the machinery of climate. It is so sensitive and so shaped by the microphysics of droplets that even small changes in atmospheric pollution can tip the scales. For instance, the increase in aerosols from human activity has, in some regions, led to clouds with more, smaller droplets, brighter, longer-lived clouds that may offset some warming from greenhouse gases. Yet the full ramifications of these changes are still emerging. The feedbacks are intricate, the details elusive. This is one of the frontiers of climate science, understanding the cloud's subtle role in the drama of planetary temperature. Step back now and contemplate the broader dance. Clouds are neither static nor eternal. They live and die, sometimes in moments, sometimes over hours. Their boundaries are porous, their edges ragged and in constant flux. Air flows into and out of their bodies, carrying moisture, energy, and momentum. The cloud is not a fixed object, but a process, an event, a continual rebalancing of forces. Even the shapes of clouds, so familiar to any sky gazer, are the outcome of complex interactions. The billowing turrets of a cumulus cloud rise where updrafts are strongest, sculpted by the tug-of-war between buoyancy and gravity, between rising air and the drag of the surrounding atmosphere. The flat bases mark the altitude where condensation begins in earnest, tracing an invisible isotherm through the sky. Higher still, the tops may flatten against a lid of warmer, stable air, a phenomenon called an inversion, halting their ascent and spreading them into an anvil shape. Each contour, each wisp and fold, is a signature of the underlying physics, a fleeting record of air's invisible struggles. Sometimes within a single cloud, multiple layers and phases coexist. There may be warm, humid air rising at the center, surrounded by cooler, drier air descending along the flanks. Pockets of supercooled water may hover alongside clusters of ice crystals, the boundaries between them marked not by sharp lines but by gradients of temperature and humidity. These internal structures are difficult to observe directly, and scientists often rely on indirect clues. The patterns of lightning, the echoes of radar, the glimmers of sunlight diffracted into halos. On rare occasions, the ballet becomes tumultuous. A simple cumulus, fed by a surge of moisture and heat, may erupt into a cumulonimbus, a thunderstorm towering 10 kilometers or more above the ground. Here, the internal dynamics reach their zenith. Violent updrafts loft droplets and ice to the stratosphere, while downdrafts drag cool air earthward. Lightning crackles, hail forms, rain pours. Yet even in such drama, the cloud's life is dictated by the same principles: the physics of phase change, the choreography of turbulence, the interplay of droplets and ice. Despite generations of study, despite an arsenal of instruments and equations, our understanding of clouds retains an element of enigma. Each cloud is unique, shaped by the unrepeatable details of its birth and environment. No two clouds are ever precisely the same, and their evolution defies perfect prediction. This is not for lack of effort. It is a testament to the profound complexity of nature, to the way that simple ingredients, water, air, heat, can combine to produce endless variety. And so, as you listen to the silence outside, perhaps catching a glimpse of moonlit clouds drifting past your window, remember that these apparitions are more than mere water vapor. They are the visible face of a hidden ballet, a dance of molecules, energies and forces, playing out above our heads in infinite variation. The science of clouds is a story with no final page, an invitation to wonder, to observe, and to recognize the limits of our knowledge. What secrets do the clouds still hold in their ever-changing forms? What stories remain locked within the whirls and folds of vapor, waiting for the patient eye or the sensitive instrument to uncover? The ballet continues, night after night, and with it, the promise of deeper mysteries yet to unfold. As the sky darkens and the world quiets, the next act draws near, where the ephemeral beauty of clouds will meet the grander cycles of weather and climate, shaping the world in ways subtle and profound. To gaze upon a sky brushed with clouds is to confront a living script, a series of shifting glyphs whose meaning has enticed and eluded us for centuries. The sky, restless and ever-changing, writes in vapor, erases and writes again. For most of human history, these fleeting shapes were the language of omens and poets. Yet as the centuries unfolded and curiosity deepened, a new question grew in the minds of observers. Could the sky's calligraphy be deciphered, not just read as metaphor, but understood as science? To begin, imagine a morning centuries ago, before the tools of modern science, before the balloon and the spectrometer. A shepherd stands in a dew-wet field, studying the heavens as his ancestors did, wisps of white trail across a blue dome. He knows by inherited wisdom that certain clouds precede storms, while others portend a clear day. He knows, too, that the sky changes with the seasons and that certain patterns recur. In these early days, observation is the first tool, sharpened by necessity, guided by memory. But the sky, with its vastness and mutability, demands more than mere recollection. So it was that, as societies grew and knowledge accumulated, humans sought to record the sky's moods. They painted clouds in frescoes, etched them into manuscripts, and, eventually, described them in words that aspired to precision. The act of naming, so fundamental to understanding, became the next tool. It was in the early 19th century, in 1802, that an Englishman named Luke Howard gave the world the lexicon of clouds. Standing in his London garden, Howard saw the need for order in the chaos above. He observed that clouds could be grouped by their form. Some were layered and sheet-like, others billowed like cotton, some drifted high and wispy. Drawing inspiration from Latin, the language of scholars, he named them: cirrus for curl, cumulus for heap, stratus for layer, and nimbus for rain. In this act, Howard transformed clouds from omens to objects of study, their shapes now a taxonomy, a first step towards scientific decipherment. Howard's system, simple yet profound, rippled outward, embraced by meteorologists and sailors, artists and farmers. Each morning, observers would sketch the clouds, note their movements, and compare their observations with Howard's categories. The first cloud atlases appeared, their pages filled with delicate watercolors and careful descriptions. These atlases became a tool unto themselves, a portable library of the sky's hieroglyphs, to be consulted and amended as new patterns appeared. But naming alone could not suffice. The next leap required measurement, and with it the invention of instruments. The barometer, born in the hands of Evangelista Torricelli in the 17th century, was the first to sense the invisible weight of air. Paired with the thermometer, it became possible to relate the changing pressure and temperature to the appearance and disappearance of clouds. Soon, a third device joined the arsenal, the hygrometer, sensitive to the water vapor that clouds both depend on and reveal. Armed with these instruments, observers could begin to link the visible forms in the sky to the invisible theatre of air currents and moisture. They noted, for example, that falling pressure often preceded the thickening of stratus or the piling up of cumulus, and that sudden drops in temperature could trigger fog or dew. Still, the sky's writing was elusive, its script only partly uncovered. To read more deeply, scientists needed to ascend, to enter the sky themselves. In the late 18th century, the hot air balloon made this possible. The first brave aeronauts, Jean-François Pilatre de Rosier and François-Laurent Darlande, rose above Paris in 1783, their balloon drifting into the realm of clouds. In the decades that followed, balloonists carried instruments aloft, measuring temperature, pressure, and humidity as they passed through different cloud layers. They discovered that the air grew colder as they rose, and that clouds were often the boundary between warm and cold strata. One of these early explorers, the French physicist Gaston Tissandier, described the silence within a cloud. One is enveloped in a white mist, cut off from the world below, the sun a pale circle. The sensation is of floating through a ghostly sea. Tissandier's words, poetic yet precise, became data points as much as inspiration. Yet balloons could only ascend where the wind allowed, and only as high as their envelopes and passengers could bear. The next advance came with the kite. In the late 19th century, meteorologists like William Eddy and Alexander Macady in the United States sent kites into the sky, each bearing a train of instruments. With clever clockwork mechanisms, these devices recorded temperature and humidity at intervals, retrieving their secrets when the kite and its cargo returned to Earth. The sky, once inscrutable, was now yielding its data in vertical profiles, revealing the stratification of air and the delicate balance that gives birth to clouds. Then, as the 20th century dawned, a new era of tools began to emerge, tools that could see the sky without entering it. The camera, invented in the previous century, became the meteorologist's new ally. Time-lapse photography revealed the birth and death of clouds, their formation and dissipation traced in silent, ghostly motion. Patterns emerged: the cauliflower growth of cumulus, the streaming tails of cirrus, the slow undulation of altostratus. Each motion, when captured and replayed, whispered hints of the processes at work: convection, condensation, uplift, and wind shear. Still, the true composition of clouds remained mysterious. What were they made of, in detail? How did their droplets form? And why did some clouds rain while others did not? The answer came, in part, from clever experiments on the ground. Consider the work of John Aitken, a Scottish chemist in the late 19th century. Aitken constructed a device known as the condensation nucleus counter, a simple box in which air could be rapidly cooled. He showed that pure air alone would not form droplets, even if saturated and cold. Clouds, he realized, needed tiny particles, dust, salt, pollen, on which water could condense. These cloud condensation nuclei, invisible to the naked eye, were the seeds from which every cloud is born. Aitken's experiments, performed in the quiet of his laboratory, echoed in the sky above, explaining why clouds often formed downwind of cities, forests, and seas. Soon after, another ingenious experiment unraveled the mechanism of rain. In the 1930s, Vincent Schaefer at General Electric cooled the air in a laboratory chamber to below freezing. Into this supercooled cloud, he introduced a pinch of dry ice. Instantly, a flurry of ice crystals appeared, growing rapidly and falling like snow. Schaefer had discovered the principle of cloud seeding, that the introduction of certain particles could trigger the formation of precipitation. His work, while controversial in its application, revealed the delicate triggers hidden in the sky's machinery. As the century progressed, the tools grew ever more sophisticated. Radar, developed during World War II to detect enemy aircraft, was soon turned upward. Meteorologists found that radio waves, when bounced off clouds and rain, returned echoes that could be mapped. For the first time, it was possible to peer inside a storm, to see the swirling bands of precipitation, the hidden updrafts, the tumultuous heart of a thunderhead. Radar images became a new script of the sky, one written not in light, but in radio waves. Alongside radar, another tool quietly revolutionized cloud study, the weather balloon, or radiosonde. Released daily from thousands of stations across the globe, these small latex spheres carry packages of sensors aloft. As they rise, they stream back data on temperature, pressure, humidity, and wind, painting a three-dimensional portrait of the atmosphere. From these daily ascents, meteorologists began to understand the layers of stability and instability that govern cloud formation. The gentle inversion that traps fog in a valley, the dry layer that erases a thunderstorm, these secrets, once hidden, now revealed themselves in the graphs and charts drawn from radiosonde data. And then, above all, came the satellite. In April 1960, the world's first weather satellite, TIROS-1, opened its mechanical eye and sent back images of clouds as seen from space. For the first time, the whole swirling disk of Earth could be seen, clouds tracing the march of weather systems across continents and oceans. Satellites, orbiting far above the storms, revealed the grandeur of hurricanes, the sweep of jet streams, the intricate dance of cloud bands encircling the poles. Their sensors, sensitive to visible and infrared light, mapped not only the shape, but the temperature of clouds, their movement and growth, their subtle variations in thickness and water content. From this vantage, the sky's hieroglyphs became a living map, updated hour by hour, shared by scientists and forecasters around the globe. Yet even as the view grew broader, the questions grew finer. What of the microphysics within a single droplet? What of the turbulence that sculpts a cloud's edge, the hidden processes that turn vapor to rain? To answer these, researchers turned to the laboratory, building cloud chambers where temperature and humidity could be minutely controlled. Here they observed the birth of droplets, the dance of ice crystals, the collision and coalescence that leads to raindrops. High-speed cameras captured the moment when a droplet shatters on impact, spawning a spray of tiny children. Lasers traced the paths of particles caught in miniature updrafts, revealing the chaos and order within a single cubic centimeter of cloud. And still, the field advances. Today, aircraft equipped with sophisticated probes fly directly into storms, sampling the spectrum of droplets and ice, measuring electric fields, recording the intricate ballet of wind and turbulence. Drones, nimble and uncrewed, dart through clouds no human could reach. Computers, running complex models, simulate the rise and fall of air, the dance of moisture and heat, the fractal beauty of clouds as they form and fade. Yet for all our cleverness, the sky retains its mystery. Each new tool, each fresh experiment opens another layer of complexity. The more we understand, the more subtle the hieroglyphs become. Clouds, those ancient scribes of the sky, still tease us with riddles in vapor. They reflect our own restlessness, our drive to know, to name, to measure and predict. But they remain, always, a little beyond our reach, reminding us that the world, for all its decipherment, is never fully legible, never wholly tamed. As dusk falls and the clouds above drift into lavender shadow, the instruments are packed away, the data filed, the experiments noted for future days. Yet the sky continues its ceaseless writing, the hieroglyphs ever-changing. Tomorrow will bring new clouds, new questions, new tools. The story of understanding is never complete, its chapters unwritten, its script unfolding with each passing hour. And so, with the twilight deepening, we look upward once more, wondering what secrets the next day's sky will hold, and what new glyphs may appear, beckoning us to decipher them anew. High above the rumble of daily life, above the shudder of traffic and the hush of midnight, clouds drift, ancient wanderers, both ephemeral and enduring. They move with a grace so effortless that their presence can slip past unnoticed, yet the world's oldest poems and its newest satellites alike have found reason to pause and marvel at their passage. In this final act, let us linger with clouds, not merely as objects of meteorological curiosity, but as evanescent companions to our own quest for meaning, as the earth's whispered secrets, shaping the weather and the imagination in equal measure. There is a certain humility to clouds, a willingness to be ever present yet never the same. A cirrus plume, swept into a fine veil by the jet stream, might stretch from horizon to horizon, its icy crystals scattering sunlight into halos and mock suns. A cumulus, buoyed upward by invisible thermals, puffs itself into a castle of vapor, only to dissolve once the air cools or its moisture is spent. Even the stately nimbostratus, bringing hours of gentle rain, possesses a dignity in its grey persistence. Each cloud is a fleeting arrangement of water molecules, and yet, in their endless permutations, clouds have become the sky's own language, a dialect of mists, hints, and portents. To look up is to be reminded of the deep, cyclical dance between Earth's surface and its heavens. Clouds are the children of evaporation, born as sunlight stirs lakes, rivers, and oceans into vapor. This vapor rises, invisible, until it meets the cooler, thinner air above. There, a transformation begins. Water vapor clings to floating dust, salt, or pollen, condensing into droplets or ice crystals. Each cloud is a congregation of millions, even billions, of these minute spheres, suspended against gravity by the restless churn of air. They seem solid, sculpted, yet if you were to fly through them, they would dissolve around you, dampening your skin, but never truly enclosing you. The paradox of clouds, tangible in form, intangible in touch. For millennia, humans have sought to read the sky's moods in the clouds' shifting shapes. shepherds and sailors, farmers and forecasters, all have learned to decipher the subtle signs. The towering anvil of a cumulonimbus warns of oncoming thunder, while a lowering blanket of stratus might portend the gentle onset of fog. Even now, with radar and satellite imagery at our command, the old wisdom lingers. Mackerel sky, not long dry, murmurs the rhyme, observing the dappled altocumulus that often precedes a front. Clouds are both the message and the messenger. Their forms a living script written by temperature, pressure, and wind. Yet clouds are not only the bearers of weather, they are the Earth's regulators, balancing the planet's energy budget with a deftness honed over eons. When sunlight streams toward the surface, a portion is intercepted by clouds, reflected back to space in a shimmering glare. Bright, thick clouds, like the vast decks of stratocumulus that can stretch for thousands of kilometers across the ocean, are especially good at this, their albedo high, their cooling power immense. At night, clouds serve a different purpose. They trap outgoing infrared radiation, acting as a thermal blanket that slows the escape of warmth into the void. It is this delicate interplay, a cloud's thickness, its height, its water content, and even the size of its droplets, that determines whether it will cool the earth or warm it. In this invisible calculus, clouds wield a subtle but profound influence over climate, their uncertainties still vexing the most sophisticated models. But perhaps the greatest enigma of clouds is their inconstancy. Trace a single puff of vapor as it forms above a sunlit meadow. For a moment it catches the breeze drifting lazily. Then, as air cools and condenses beneath it, the cloud grows, billowing outward. Sunlight pierces it, illuminating its edges in silver. Soon the wind shifts. Dry air intrudes, and the cloud begins to unravel. Droplets evaporate, returning to invisibility. Within minutes, the cloud is gone, the sky as empty as before, except, perhaps, for a memory of its passing. It is this dance of creation and dissolution, of becoming and vanishing, that lends clouds their aura of mystery. They are always in motion, always becoming something else. Artists and poets have long understood this, finding in clouds a symbol for impermanence, longing, and transformation. The Japanese haiku master Basho wrote of clouds drifting over the mountains, their forms echoing the restless thoughts of the traveller. English painters, from Constable to Turner, found in the sky's shifting drama a subject worthy of endless study. Even today, to watch clouds is to practice a kind of mindfulness, an attentiveness to change, to beauty that insists on its own impermanence. In the billowing arc of a summer cumulus, one may glimpse the outlines of mythic beasts or forgotten continents, each shape lingering for a heartbeat before melting into abstraction. Yet, for all their transience, clouds are repositories of ancient water, molecules that may have cycled from ocean to rain to river and back again, countless times since the earth first cooled. Each drop in a cloud may have once fallen as snow on a Pleistocene tundra, or surged through the sap of a prehistoric forest, or quenched the thirst of a long-extinct animal. The water within clouds is a living memory, a thread that binds the past to the present. When rain falls, it is not simply water returning to the ground. It is the renewal of a process older than mountains, older than any living thing. Within this cycle, clouds are not passive bystanders, but active architects. Consider the monsoon, that great seasonal pulse that brings life to half the world's population. The monsoon's rains are born in the slow, patient gathering of water vapor over the ocean, drawn landward by changing winds. As the air climbs, cooling and condensing, towering cumulonimbus clouds erupt into being, their updrafts so powerful that ice crystals and hailstones can be lofted miles above the earth. Lightning flickers within, thunder rumbles, and then, at last, rain falls, drenching fields and forests, filling rivers, and sustaining life. Without clouds, there would be no monsoon, no replenishing of streams or aquifers, no green renewal after the dry season's austerity. Yet clouds can also withhold. In times of drought, the sky remains pitilessly clear, the sun's heat untempered. Farmers scan the horizon for any sign, a distant haze, a faint wisp that might promise relief. Such longing for clouds is a theme as old as agriculture itself. Ancient rituals and prayers have been offered to coax rain from the sky, to persuade the clouds to gather and give. In these moments, clouds are not mere weather, but arbiters of fate, wielding power over harvests and hunger. In the high latitudes, clouds wear a different guise, delicate, icy, and rare. At the edge of night, after the sun has dipped below the horizon, the mesosphere sometimes becomes a stage for noctilucent clouds, the highest in Earth's atmosphere. Composed of tiny ice crystals, these clouds catch the last rays of sunlight, glowing in ghostly blue and silver against the deepening twilight. Their appearance is a subtle signal of change, tied to the movements of water vapor at the very edge of space. To witness them is to glimpse a secret world, a domain where clouds are born not from warmth, but from the chill of near emptiness. Closer to the poles, clouds take on another role, shaping the flows of air and water that define the planet's climate. Over Antarctica, swirling masses of stratocumulus and polar stratospheric clouds participate in the formation of the ozone hole, their icy surfaces providing a stage for chemical reactions that would be impossible elsewhere. Even in the frozen fastness of the poles, clouds are agents of change, their presence felt in the chemistry of the air and the fate of the sun's ultraviolet rays. Yet, for all their scientific significance, clouds retain an irreducible element of wonder. They defy easy classification, their edges dissolving into ambiguity. The World Meteorological Organization has named and catalogued their forms, but the sky still invents new variations, subtle gradations that resist the tidy boxes of taxonomies. Asperitas, a recently recognized type, undulates in dark, wave-like ripples, evoking a turbulent sea. Lenticular clouds hover over mountains, smooth and lens-shaped, mistaken for the ships of legends or the craft of visitors from other worlds. Mammatus dangle from thunderstorm anvils, pouches of cloud that seem to turn gravity on its head. Each new sighting is a reminder that the sky is not fixed but alive, capable of surprise. There is, too, a quiet democracy to clouds. Unlike the distant stars, which are fixed and cold and unreachable, clouds are close, sometimes so near that you can walk through them, as in the morning fog, or feel their chill as mist. They are shared by all who look up, regardless of place or station. In cities, their reflections shimmer in glass towers and puddles. In the countryside, they cast moving shadows over fields and hills. Children and elders alike find faces and stories in their shapes. To look at clouds is to participate in a tradition as old as humanity, a communion with the world above. Yet clouds are not only things to be gazed upon, they are things to be listened to in the sense that the earth itself whispers through them. Their forms and movements tell us of the warmth of the sea, the direction of the wind, the arrival of a front, the approach of a storm. To learn the language of clouds is to become attuned to the subtle rhythms of the planet, to read its moods and anticipate its gifts and challenges. In a time when the climate is changing, these lessons are more precious than ever. Scientists study clouds not only for their beauty, but for the critical role they play in feedback loops that may amplify or mitigate warming. The question of how clouds will respond to a hotter world is one of the great unsolved mysteries of climate science, a riddle written in vapor awaiting interpretation. But beyond their practical importance, clouds invite us to contemplate our own place in the cosmos. They remind us that, though we are earthbound, our lives are shaped by forces that swirl high above. In the mutability of clouds, we see reflected the impermanence of our own days, the inevitability of change, the beauty that can be found in what will not last. To watch a cloud drift and dissolve is perhaps to practice a gentle art of letting go, to find comfort in the cycles that shape both weather and life. Some nights, as the last light fades and the world grows quiet, a veil of cloud draws across the moon, softening its face. The sky becomes a canvas of shadows and shifting veils, the stars briefly hidden, then revealed. It is in these moments, when the boundary between earth and sky blurs, that the true magic of clouds reveals itself. They are more than weather, more than mere physics. They are the breath of the world, the visible trace of water's eternal journey, the earth's whispered secrets, forever drifting just out of reach. And so, as you lie beneath the gentle watch of the night sky, perhaps you will listen for those whispers, the hint of rain in the air, the promise of dawn reflected in a glowing bank of cirrus, the slow, silent passage of water on its ancient path. For in the presence of clouds, we are reminded not just of the science of the sky, but of the wonder that comes from simply looking up and letting the mind wander where the clouds may lead. As our journey through the soft, swirling realms of clouds gently drifts to a close, may your thoughts float like cotton wisps under a twilight sky, quiet and full of wonder. Let the quiet hush of the cosmos cradle your dreams until we meet again, ready to unravel more mysteries beneath the comet tail, fading into the hush of space. Sleep well, and return soon for another tranquil voyage through the stars.